Hello, students. I hope you all are doing wonderfully well. Now, in this video, we are going to move to the next solids of chapter of surface area and volumes, which is a sphere and a hemisphere. The surface area of a sphere is equal to 4 pi r square. The curved surface area of a hemisphere is 2 pi r square. And the total surface area of a hemisphere is 3 pi r square, because in the total surface area, the top circular surface also gets counted. So pi r square gets added to 2 pi r square to complete 3 pi r square. Now these are the real life examples of a sphere and a hemisphere. That's a football, that's the globe, that's a serving bowl, and these are the lemons and the sweet limes that is enjoyed so much in a hot weather. We are now going to move to exercise 13.4, and I'm going to start with the first question, second part. Find the surface area of a sphere of radius 5.6 centimeters. The surface area of a sphere is 4 pi r square, and you are going to substitute the values as are given. Now over here, 5.6 cancels with 7 to give us 0.8. The rest of it is multiplied and the surface area comes out to be 394.24 centimeter square. Next, I'm taking up the second question, third part. Find the surface area of a sphere of diameter 3.5 meters. If the diameter is given to you, you have to find the radius. So radius of the sphere is equal to 3.5 by 2 meters. Substitute the values in the formula. Now I'm just going to take the cancellation forward over here. I've cancelled 3.5 with 7, that's giving us 0.5. And both the 2's that you see in the denominator get cancelled with 4. So what is left is 22 into 0.5 into 3.5, which is giving the area as 38.5 meters square. Now, two parts of the first question and two parts of the second question you will try yourself. Next, I'm moving to question number 3. Find the total surface area of a hemisphere of radius 10 centimeters. Use pi as 3.14. The total surface area of a hemisphere is 3 pi r square. Substitute the values. What you see over here is 3.14 gets multiplied with 10 into 10. Now, two tens when multiplied lead to 100. And when you multiply 3.14 with 100, you get rid of the decimal. Completely. That's 3 into 314, which is equal to 942 centimeters square. Question number 4. The radius of a spherical balloon increases from 7 centimeters to 14 centimeters as air is being pumped into it. Find the ratio of the surface areas of the balloons in the two cases. So here, when r is equal to 7 centimeters, the surface area of the balloon is equal to 4 pi r square, which is 4 pi into 7 centimeters square. When the radius increases to 14, the surface area of the balloon will move to 4 into pi into 14 centimeter square. What is the ratio of these surface areas? I have taken the first value in the numerator and the second value in the denominator. And my advice is to follow this rule in every question so that the ratio or the final answer matches with the book answer. Now here, what you notice is 4 and pi gets cancelled. When you cancel 7 and 14, you get a 2 in the denominator. When you cancel 7 and 14, the second 7 and second 14, you get another 2 in the denominator, which is going to make it 1 by 4, and the ratio becomes 1:4. Next, I move to the fifth question. A hemispherical bowl made of brass has inner diameter 10.5 centimeters. Find the cost of tin plating it on the inside at the rate of rupees 16 per 100 centimeters square. Now over here, the radius of the hemisphere is equal to 10.5 by 2 centimeters. My advice is to not change this further into decimals. That means not try and remove 2 in the denominator. It's going to become difficult to work with a lot of decimal when you're calculating. All right, inner CSA of the hemisphere is 2 pi r square. Substitute the values. So I'm just going to explain the cancellation over here also. I'm cancelling 10.5 with 7, I get 1.5. 1, 2 gets cancelled directly. The second 2 gets cancelled with 22 and gives us 11. So this is what is left after cancellation, and the value comes out to be 173.25 centimeters square. Now the cost of tin plating is given as 100 centimeters square equal to rupees 16. So what is the cost of tin plating 1 centimeter square? That's going to be rupees 16 by 100. So the cost of tin plating 173.25 centimeters square is going to be rupees 173.25 into 16 by 100. Now my advice over here is to multiply the numerators, because when you are given 100 in the denominator, it's very, very easy to move the decimal point. Don't try and make cancellations over here, because then you will not only have to multiply, but you will also have to divide. So over here, if you can see, I have only multiplied the numerators, which is giving me 2772 upon 100. And now it's very easy for me to put the decimal places. Over here, the number of zeros will indicate the position of the decimal, which is giving me 27 rupees 27.72. Question 7. The diameter of the moon is approximately 1/4 the diameter of the earth. Find the ratio of their surface areas. Now here we are going to start with the diameter of the earth as d. The radius of the earth is going to be d by 2. Diameter of the moon is then going to be d by 4, and the radius of the moon is going to be d by 8. Now here you can see we are coming across two different radii, therefore two different notations for r are required. Surface area of the moon upon surface area of earth is equal to 4 pi small r square upon 4 pi capital R square. Now 4 pi gets cancelled in the numerator and denominator. D by 8 into d by 8 is written first, and d by 2 into d by 2 in the denominator is going to undergo its reciprocal and become 2 by d into 2 by d. Now both the d's get cancelled with the 2 d's in the denominator. If you cancel 2 with the first 8, you get 4. If you cancel the second 2 with the second 8, you get another 4, which is going to give you 1 by 16, and the ratio becomes 1:16. Next, we are going to move to question number 8, and I'm going to leave this with a hint. It says a hemispherical bowl is made of steel 0.25 centimeters thick. The inner radius of the bowl is 5 centimeters. Find the outer curved surface area of the bowl. Now over here, you are given the inner radius is 5, and the outer radius is going to be the inner radius plus the thickness, which is 5.25 centimeters. With this value of outer radius, you have to work out the outer curved surface area of the bowl. Question 9, which is a good question. It says a right circular cylinder just encloses a sphere of radius r. Find the surface area of the sphere, curved surface area of the cylinder, and ratio of the areas obtained in 1 and 2. Now over here, the radius of the sphere is given to be r. So what is going to be the surface area of the sphere? You will have it equal to the formula, which is 4 pi r square. Then height of the cylinder. This is the height of the cylinder. which is going to be equal to the diameter of the sphere. And the diameter of the sphere is equal to 2r. So CSA of the cylinder, the formula is 2 pi r h, and h can be replaced, which is the height of the cylinder, with 2r, and the CSA of the cylinder is equal to 4 pi r square. What is the ratio of the areas obtained in 1 and 2? Since both the areas are identical, when you take the values of the areas in the numerator and denominator, you will get 1 by 1, and the ratio is going to be 1:1. Questions 6 and 8 of this exercise you will try yourself. Next, I move to the challenge question. It says a solid cube of edge 5 centimeters is surmounted by a hemisphere of diameter 4.2 centimeters. Find the surface area of the entire solid. So you can see a cube over here with the edge equal to 5, and a hemisphere is being placed on the top surface of the cube, and the diameter of the hemisphere is 4.2 centimeters. You have to find the surface area of the entire solid. Thank you all. And with this video, we are able to cover the surface areas of a cuboid, cube, cylinder, cone, sphere, and hemisphere. The next video is going to be about the volumes of the solid shapes. Thank you for watching.